Welcome to a new test and teardown video. This time it's something completely different. This one is a SwissEcho. Maybe this one is a model 462. I'm not quite sure it is that exact model, but we're going to find out. Of course, it is in a very bad condition. It is not working, not at all. So I want to try and see if I can figure out what is going on with this thing. Oh, so there's a tape in there and recording heads, and it's going in and out, and we can adjust the feedback that we hear. We put this back into the recording, and this way we can change all sorts of things on the tone and the knobs, they are way off, and this will be selection of the different heads, and they are placed along the tape, and this way you change the timing. So let's look a little bit on the internal parts, and down here, I think this is the erase inductor. So it's an oscillator together with a power tube. So it's actually erasing quite powerful. And here is a motor. And if we look down the hole here, we can see a little rubber band that has fallen off. Let's get some, yeah, see? So I imagine there is a rubber band from the motor all the way to this is called the capstan. And this one can rotate. And this is the one that pulls the tape around. And this rubber wheel here pushes, it's supposed to be tight to the capstan. And then the tape is held and pulled by this capstan around at a fixed speed. Here is a little ball bearing, and it can move quite nice. There is a little problem with this one. I don't know how visible that is, but it's full of oil under here. You're not supposed to be able to see oil and stuff in tape recorders, at least not near where the tape is. You can imagine the sides of the tape touching oil, and it's gonna go and destroy everything here. And tape don't really like any kind of liquids, by the way. So I think I need to be able to take this apart somehow. And then here is this is a fixed piece of metal, and the tape goes around this one, and I bet the idea is it goes this way and then here, but there's something completely missing, because from this point on, how do I get back to the beginning? There's a tube in the way, so that means there is another roller that is missing. I think it is the springy arm or something, so it can be anywhere. It can even be up here. I mean, it doesn't really matter where it is, as long as it goes from here and then somewhere else. But you can see a ton of holes. This one's been modified a million times. So this is the motor. They just drilled some other holes, and I think this is because of the rubber band, and they couldn't find exactly the right type of rubber band. So okay, let's just move the motor, and now the rubber band will fit. So a very practical solution, right? And then we got the erase head. So when the tape goes in, it is first erased. And I like to explain, of course, the circuit, how that really works with the oscillator and all that. And this is the recording head. So the recording head and the first echo head. So this is the first playback head. We've got 4 playback heads, and they are, of course, directly connected to the 4 switches right here. So the playback heads, they have exactly the same distance between them, and that is just so it's easier for the user to figure out what kind of delay they want. You can, of course, enable more and more. You can plug in all 4 heads at the same time, so you listen to all 4 instances of when something comes, and then you can feedback this at a variable level into the recording again, causing all sorts of fancy effects. And I think that is why it's important they have exactly the same distance. Otherwise, it's going to cause all sorts of weird results. Somebody added some nice stickers here to call the tubes 1, 2, 3, and we got actually another tube down here. So this is one of those EM84 indicator tubes, and this just indicates the recording, the recording level. So you just adjust for correct recording level, and then you can of course just crank up and down volume. Volume is just the output that you're listening to, so this is not affecting anything. So so that was the fast little walkthrough of what this is, and as you can see here, I got a lot of mechanical problems, with challenges, I would say, and there's also this how to open this thing. We can see the funny angles. So the front is tilted back, and that is definitely a design decision. And we got some different inputs. We got 4 inputs, and I believe it also says input here. No, it says output. Okay, here we go, output. And we got 4 inputs, and you can individually mix them here. They are just additive mixed, but I think one of them goes through a high impedance, and then the others, they go via another tube, and so for isolation or for some, I don't know exactly why that is the case really. We got a remote that is removed. That is good, because this is completely useless. And then there is the original label, and as you can see here, the type number is for whatever reason scratched away, so this is not helping me so much. We got the voltage selector here, and I believe it is set for 220. At the moment we got about 230 to 240, so I should probably move this a little bit. I will measure the voltage inside and see where we are, and if that is a good or a bad idea. If we look in here, we can see a lot of new solderings. So I think all this has been redone. Maybe the jack's been changed. Everything here is a little bit loosey. I mean, it's more or less all screws I touch, they're just loose all over the place. So this is the right side of the unit, and I think this is the erase oscillator and driver for the erase head. We got some bulbs here, and this is the, I don't know exactly what that is. One of them will be power on, right? And I don't know exactly why we got 2 bulbs there yet, so I will figure that out real soon. Wires, they are a little bit loose. Yeah, this is the mains voltage selector that is also loose. More or less all screws are loose in this, yeah. I really don't like this, the idea they had. Yeah, look at this. We've got the screws here, and I need to be able to take this up or down or bend it, or I don't know how, okay, all the wires, they go maybe this way. So I need to figure out how to flip this so I can access everything and still be able to operate the, yeah, I mean, I don't know, how do I do that yet? And to be able to handle those 3 screws, you need to take away this plastic part. And to be able to do that, you need to unscrew the 4 screws here. And I think this is the only thing that holds this front plastic. Maybe it's even glued as well. I mean, this is not service friendly in any way. And this bothers me quite a lot, because also when you want to change the rubber bands or something like that, those things just don't last forever. So this is annoying. So I need to figure out a way to solve this so this is not causing a problem in the future. Maybe I could, I have an idea about maybe I could just glue the screw in. So that means the screw is always here. And then I just only handle the little nuts here on the back. And then I don't need ever again to get in here. I think that is a good improvement. What is the idea here? Why is there is something missing here? We got, of course, a lot of screws missing. But I think the idea is we can remove the bottom plate and maybe access everything while everything is still together. Maybe that is the thing, because we can see those little screws here. They're holding some side part, you see? And there's also a screw here, so maybe this is stable enough. I definitely want to remove the bottom plate here, and then we can maybe investigate some more. So we are inside the bottom of this unit, and I must say, look at that. Everything is quite dirty and a little bit of corrosion and stuff. I bet this unit was on storage for quite some years. And this is the solenoid that is activated by this foot switch. And this pushes this rubber roller to the capstan, and this way moves the tape. So the whole idea is you can warm this up and have everything working, because it's tube based. And then also you need to spin up this big heavy motor and this big hefty here, and this stabilizes the movement. Look at that. This is the rubber band I was talking about. Somebody called this O-rings. And I need to measure the exact dimensions so I can order a new one, and without touching it too much, because it's probably going to bend and crack. So I'll try and save this for all my measurements. Also, the motor is an AC induction motor, so we got 2 windings in this one and some capacitors, but I can't find the capacitors, so I need to look at that as well, because I feel the motor can spin if I can't hit the shaft right now, but it's actually moving quite good from the other direction, and also this one is moving good. We got a lot of modifications that was done to this unit over all those many years. And we got tiny little circuit boards, a transformer there, and a lot of fuses, and they are of course a little bit corroded. And here is the power supply entry. This needs a little bit attention. I'm not super happy about all that. This is okay. Yeah, everything is completely loose. But there is a good few days of work and entertainment left in this one. See, that will be the cables for from the 4 heads, and you simply just enable the different heads directly into a common rail that goes via another shielded cable to the amplifier. It looks like I got a little bit of a research. Oh, here's a rectifier that was glued somewhere. We got some tiny little rectifier diodes. And that is, of course, the high voltage capacitors. So I got an idea how to measure the O-ring, or the drive belt, whatever you want to call it. So the diameter of this is quite easy. That's 2.5 millimeters. So how do I estimate the inside diameter of this one? So I find something. This piece of metal here is 97.7. Let's just say that is the outside diameter of this one. And then I carefully try to pull this like that. And now I can measure what is missing, and then I can do the math and figure out what diameter is it really, and then I can order a new one. I think that is what I want to do. So here's the status. I did a lot of cleaning here on the circuit board so I can easier see what's going on and avoid all sorts of dirty corrosions and arc overs and all that. Adding a little bit of text so it's easier for me to figure it out while I'm here. We got this coax cable. I don't know exactly where that is going. That is weird. And I'm cleaning up the mains mess. Everything here around mains entry, high voltage, filament, everything here is a complete mess. And also the voltage selection. I so far repaired 2 of the wires. And let's see if I can focus on that. Can you see the red wire here? See, we got, oh, look at that. So you know how it is with those little copper wires. I mean, we got some varnish on top of them. So that means you can't really solder on them. You need to handle this. So this is the kind of stuff that I need to work with. And it's probably the same with most of them. And yes, a few down here I already repaired. Adding new wires and solder them down here, and then it's easier. So now I just need to do it all right. So I'm actually started to do the power up very, very slowly and carefully. And look at that. I got a shorted anode supply for the erase oscillator and power driver, and look at that. We got 2 of those capacitors here, and they are melded together, and this create a short. So that was a little bit difficult to find. It's not super easy to access. I want to share this fantastic moment with you. Can you hear what's going on? The motor spins. And it's upside down, so it's not hanging correctly in the bearings. I got AC filament a little bit low and got my 265 volts. This is actually the voltage that goes to my entire amplifier board, and this is under load and all that. I have found so many problems. Let's try and turn it off. So wires here for the different high voltage supplies, they were mounted wrong. So high voltage from the rectifier bridge right there goes to the first capacitor. Then it goes via a resistor to the next. And this is the high power anode supply that goes to the erase oscillator driver. And then there is a 10K series resistor and another capacitor. This is, of course, the super filtered high voltage that goes to the amplifier board. But they did it the other way. And also, I had a shorted capacitor in this oscillator. And what do you know? It turns out it was those 2 capacitors here, and they were right next to each other. They melded together. I don't know if we can see this, but this side here and this side here melded together, causing a short. So now I changed them, and I'm a little bit curious to see if this oscillator works, but I will just try and run it without this oscillator, because I don't want the erase head running. I want the playback system to say something. And now I got the motor spinning, but I still need this O-ring to make the capstan running. So I need to simulate some signal and see if I can get some audio through. So I definitely think something is going on. You can see this indicator here is blinking quite a lot, and it has something to do with this modulation here. So I can change it, and then it turns completely off. So something is alive. We got some volume, and I turned on the head 1. So head 1 should be this one, right? Here we got my headphones, and can you hear? It's clearly number 1. So this is just an inductor and a signal generator. It will create a magnetic field, right? And this is exactly what they detect. So let's try and play with head number 4 instead of head number 1. See? Now it's head number 4. Yay! So we got something that's working! Oh, look at that. It's completely soaked in oil. And this can't be good. What's gonna happen when the tape goes through here and get completely soaked? So we need to clean this and have it nice and clean. But what I really want from this is the design. I want to steal the whole idea, and then I want to 3D print something so I can make the missing tape steering things. This is real nasty. But it's not a bad idea to use a bearing like that. But maybe there's other ways to do it, but we'll see. Here is what I think. Of course we need a steer right next or in front of the capstan, so all that is perfectly fine. But we can't have the tape going all the way through this tube. And look at the marks right here. If I'm not mistaken, there was originally another one right there. And then they figured out, oh, the tape can go this way, but you can't have it this long way and then into the capstan. It's going to go up and down here, and it's going to be a problem. So you need to have this one as well. So we have a missing wheel right here. So I want to go here, and then I want to use, see, we got some holes here, we got some holes here, and I want to use some of these holes to make a little spring arm. So, and then I want to go probably this way up here, and then I want to go up here, and then erase head, recording, and the 4 playback heads. I'm afraid this is going to be the never-ending story. So I've measured, as you can see here, the different important measurements. So the height of this one is 8.3, and then the gap in here is 6.5. So this is just a little bit over this 1/4 inch tape, so it can still move a little bit without getting stuck. And there's a nice ball bearing here, and this is I think this is a home brew design. After I cleaned everything and removed all the oil, all this is perfectly fine. This is not a bad design, but it's just wrong. So there's a problem with the height. See, this 8.3 and this height over here, this is the steering, the tape steering for the heads, the entry and the exit for the heads. We got this measurement here. So we got a little bit extra headroom for the tape. But see, it's a completely different height. So this big distance difference will make the tape go a little bit up and down in the machine. This is not good for tape transport. It must be exactly the same height as much as we can make it. So this is our bet. This is completely wrong. This is not the original one, so I need to make my own. And if we look a little bit again at my unit here, we got, of course, these. But I think if I move this one to this hole and be sure to keep the right height, then I don't need any more steering here. Then I can go directly here. And I need to figure out a way to redo this one so it's the right height. And then I need to figure out everything else. I haven't yet exactly decided how I will do all that. But I will start in the small. See, here is the 3D design that I made for the little roller wheel, and I made it two parts, where you press fit these and then you stick in the ball bearings into each individual part. And I also made the part in here so it's not rubbing the edges of the tape. You can see here a little cut half how I made it. The reason for doing this is so I can print both halves like that, and the other one, of course, like that. Super easy. And here we go. I got the part. And it was so much press fit. I needed, of course, tools to press everything together, so I don't need any glue or anything, and it's super good and accurate. So it's actually specially designed also to fit an M4 screw for, look at that, how I can polish this one using a super fine little file and a drilling machine. So this is also, this is just a little intermediate step before I click these two parts together. You can really make a lot of cool things with a 3D printer. I am about to get a little bit excited about all this. It turns out to be a lot more fun than first anticipated. And it looks really good now. I just need to 3D print a few more. But look at that. They spin really nice and good. And there isn't a lot of flippity floppity in here. Anyhow, it's really good. I'm still fighting a tough fight, figuring out how to solve all those things. But so far, I came up with this. I need to go down here. Now we have good distance to this hot tube. And then we're gonna go via this wheel. You need to imagine the tape is a little bit inside, like this. So it goes exactly through the capstan. Then I want it to go perfectly straight, because when the solenoid is not activated, I want the tape to go, just barely touch the capstan. That could be fantastic. Then I want it to go around here. I need another one right here. Let's just imagine this one is here. Then it makes perfect sense. This way we go around, right? So let's pretend the tape goes in this direction to this hole. So imagine we are right here. Then it's gonna go like this. But I want this one to be spring loaded, so it will be able to move like that. So this is the hole for the joint that can move. And then I want to have a little spring here that goes to this one. I think this is possible. At least that is what I'm going with so far.